In 2008, CERN unveiled the Large Hadron Collider to the world in hopes of finding the Higgs boson, a theoretical particle which, if found, would be the last missing piece to confirm all our ideas of physics up to that point to be correct. The LHC is made up of 4 rings and is the biggest particle collider in the world. Hydrogen gas is pumped into the first ring, where the hydrogen's atoms are given energy in order to remove their electrons, leaving only protons. These are then sent down a second ring, accelerated, sent down a third ring, accelerated again, and then sent down a fourth ring at 99% the speed of light. At this speed, 2 beams containing protons are ran parallel to each other in opposite directions. They're held in place by very strong magnetic fields, and when researchers are ready to collide them, they can simply deviate them towards each other and let the particles collide. This allows researchers to create particles that aren't normally in existence since they're so unstable, particles such as the Higgs. Each collision is essentially photographed by one of 4 detectors around the ring, and then that data can be analyzed later. So when looking for the Higgs, physicists knew that they couldn't directly observe it since it disintegrates so quickly. However, they could look at what it decayed into, such as 2 photons. But 2 photons could also come from other decaying particles. So what they did is they made a graph. They related the number of events with the corresponding diphoton mass, meaning the mass of 2 photons. Now if the Higgs didn't exist, they would be able to predict a graph that looked something like this, an exponential graph with fewer events at higher mass. However, what they found was a bump. This means that at a certain mass, there were more events recorded than predicted, meaning that there was a particle unknown to them, and thus they couldn't predict its behavior. After further calculations, this was in fact found to be the Higgs, and all our pre-existing notions of what physics are were validated. After this breakthrough, CERN went on using the LHC in different experiments, but a lot of people got worried. It was thought that a black hole could be created in it and destroy the Earth. Now this isn't true, but CERN has admitted that they can create a black hole in the LHC. So why is it still safe then? Well, to understand this, we need to look at 2 characteristics of black holes in the LHC, their lifespan and their mass. First of all, any black hole created in the LHC would have a very short lifespan. This is due to what's known as Hawking radiation. Essentially, at the edge of any black hole, pairs of particles get separated. Some particles go off into space while others get sucked in. By calculations, we know that those going into the black hole give it negative mass. In other words, the black hole is sucking its own perimeter into itself and caving in. A black hole created in the LHC would be so small that its own Hawking radiation would make it die out instantly. Which brings us to its mass. Any black hole that appears in the LHC will always stem from a particle-particle collision, meaning that its initial mass would be extremely small. Some might say that a black hole can still eat up a lot of matter before it dies out, but we have to understand how it does this. It uses its gravitational pull, which is proportional to its mass. So a black hole in space looks like this, but a black hole in the LHC would look something like this. It wouldn't be able to pull in more than a few particles into itself, and due to its Hawking radiation, it would still die out in less than a second. So the LHC is definitely safe to go on exploring the cutting edge of modern physics, one experiment at a time.